This is part 2 of the Kyosho Rampage Pro electric conversion build series. As you can see, I have a fair amount of the rear end assembled here. I have the rear suspension assembled and the rear gearbox. There's actually a fair amount that goes into this that is worth explaining. I'll start with the rear suspension, if you will. Originally, my motivation was to try to use modern CVAs or CVDs as a substitute for the original Pro X and Rampage Pro universal joints, because these universals are, rather hard to find. You basically have to buy maybe a whole other car, just as a parts car to have spares for this. So I thought initially that I would use something like an RB5 or an RB6 universal, which is the right length. So if you measure it out, let me see if I can find it here. Got them somewhere. These guys here, these are 65.5 millimeter dog bone length, which are exactly the same length as what you would use on a Rampage Pro or a Pro X. But the problem is this universal joint right here, where the cup fits into the ball end, this is actually a little bit too wide. And so when you try to mount that into this housing here inside the rear hub carrier, it'll fit, and then when you put it on the suspension arm, it'll grind against the suspension arm. So you could theoretically still use it. You would just have to grind out part of the arm to make it fit. And I'm a little hesitant to do that on these older parts. I'd rather try to keep them as original as possible. So I tried finding other types of universals, like there's this other Kyosho part, LA303. It's a 65.5 millimeter swing shaft, which is this type of joint, same thing as what the original has. But again, this whole assembly here for the universal joint is a little bit too fat, so it doesn't fit very nicely in this opening. And if you look closely, you can see that the way that the rear hub carrier is designed, it actually recesses down a little bit relative to the arm, which kind of pushes the whole joint down and potentially against the arm if this universal joint is too fat. So the original Rampage Pro and Pro X universal joints are slimmer in order to fit in that sort of smaller opening. So I ended up just going back to the original parts for this. For the wheel hexes, I went with RB5 wheel hexes. These are actually a little bit wider than the original Rampage Pro and Pro X wheel hexes, so you will have a little bit more rear width relative to using the original parts. I still have the original parts somewhere in that mess, so I could go back and use them if I wanted, but the reason why I chose these was, I guess, because they just look a little nicer, and the pin that goes through the wheel axle is that you use with this wheel hex. It fits smoother through that hole in the wheel axle. The original pin that goes through this, you have to use pliers and press it in, kind of like an old RC10. So I wanted to use something a little bit more modern there. As for the suspension itself, I did find myself having to drill out the inside holes here that the hinge pin mounts through on the suspension arms, just to get less bind. Otherwise, it was very bindy. It didn't doesn't move very smoothly unless you do that. The suspension itself is kind of interesting. It comes with a front and a rear inner hinge pin mount that has little plastic balls that go into each opening, and then the rear mount comes in a parts. This all comes in a parts package. And the rear mount, you can either use a 3-degree block or a 5-degree block, depending on how much toe-in you want. I'm starting here with the 3-degree block, and the way they mount onto the chassis, there's just 2 screws, one here, that comes in from the bottom, and the same thing for this front piece here. So the default setting gives you a little bit of arm kick up. You can maybe see a little bit there, the kick up angle. So if you wanted to adjust kick up, you could say put some spacers under this one to flatten it out and reduce the rear kick-up, or sorry, anti-squat. Kick-ups up front. To reduce the rear anti-squat, if you wanted to increase rear anti-squat, you could either lift up this end with spacers, but it's already a very tight fitting between this block and the bottom of the gearbox. So lifting up this end is probably not how you'd want to increase rear anti-squat. If anything, you would probably take this piece and maybe shave it down, X amount of millimeters from the bottom here, so that the whole thing recesses a little more, and that'll give you more anti-squat. And then if you want to get back the stock anti-squat setting, just put some spacers under there. I didn't try modifying that yet. I'm just going to keep that stock for now. So onto the gearbox. So the gearbox took a fair amount of work to really get it right. And there are a few things here. Starting with the internals, I went over in the last video how this gearbox kind of works, and you have the differential in the middle, and then these two gears at the bottom where the outdrives are. And what I was finding was, as I was tightening the gearbox down, I was getting some bind. And what ended up happening is the part where the thrust bolt exits. So the thrust bolt goes in this way, and it exits out this way. And I think it was grinding a little bit against the other half of the gearbox. It was either that or the little nut that it screws into. Let me find that here. That's this, thrust bolt goes in this way, and it screws into this nut right here. And this was protruding out just enough from the entire housing to grind a little bit against the part of the gearbox that it mounts into. So I just took a little razor blade and just lightly shaved out a little bit of that opening to prevent some of that grinding. That did help a little bit, and it spins relatively freely. There's one section where it's maybe the gears are catching just a little bit. Maybe it's a more of a mesh problem than anything else, but it's relatively free now, so I'm happy with that. Now, as for mounting the electric motor mount and the slipper hub, that's another adventure. So I mentioned, I think in the last video, when I got the motor mount, it's a flat piece down here, but I actually had to cut it out a little bit so that it would wrap around this front rear inner hinge pin mount. Otherwise, you just can't mount it. It won't go through. So, just mark it out, take a Dremel, cut it out. Actually cut out a little bit more material than I needed to, but that's okay. I'm not too worried about that. You will find, though, that because of the way this particular motor mount was designed, and there's nothing wrong with the design, it's just a matter of how much space you have to work with here. So one of the screws for the motor mount is right at the bottom here of this gearbox, and it runs pretty close to the top of this hinge pin mount. So when you remove material from the bottom here, just make sure you don't remove all the way up into that screw hole. You got to give yourself a little bit of slack there. So there's a couple of millimeters of slack, if you will, or margin for getting that removal done correctly. Okay, so that all fits fine. And then the next part here was the inside slipper hub. So you may remember, I'll just show you from the manual, the original slipper hub on this car actually has kind of a disc on the inside that's part of the brake assembly for the nitro version of this car. And what that ends up doing is, because you have to accommodate that, the way the slipper hub mounts is it pushes this whole assembly out a little bit. So when you mount a motor, let's take a standard motor here, and you mount it through, looking from the top, you only have from the tip of this shaft so much space that you can run a pinion gear out in order to mesh with a spur gear that's kind of way out here. So what I had to do was take this slipper hub and remove that sort of inside brake disc, if you will, so that would allow me to take the actual mount here where you see the drive pin on the input shaft mounting into the sort of hub. I had to take a Dremel and grind that opening down a little bit so that I could slide the hub further in this way, and that would move the whole assembly in a bit so that with the motor mounted on the motor plate, okay, the output shaft here from the motor doesn't line up perfectly, but it is just enough space to mount a pinion gear with the grub screw on the pinion, close to the end, maybe a few millimeters in, and still have enough room to mesh a pinion to the spur gear here. Okay, so another way to do this is to take the slipper hub from a Pro X, which doesn't have all of that material on the inside, the sort of brake disc or brake pad material that you have to remove. It's not there because this is Pro X is an electric gearbox. So you can just take that inner slipper hub and then, extend that mounting slot, right? This little guy right here. You could extend that with a Dremel and then just mount that. The reason why I actually tried that out on this part first to test fit it, and then it worked. But because this part I think is made of steel, I just put this all back together. And this part here, this hub is made of aluminum. It's lighter weight. I wanted to see if I could keep the aluminum parts on here to minimize rotating mass. So it was a fair amount of dremeling work. If I had a proper machine shop, I might have done a cleaner job. You can see it's a little scarred back here, but that's okay. Everything works fine. It runs freely. Now, one thing to note, if you are going to do this and you recess the slipper hub further back along the input shaft, it does offset things a little bit, because on the input shaft you have 3 different diameters of shaft here. So when this slipper hub ends up getting pushed further back per this modification than the original design, the bearing you use here that slots onto the input shaft is normally a 4x8 bearing. You have to use a 5x8 bearing because this bearing would normally fit here. Now it has to fit here, which is a 1 millimeter larger diameter. So change this to a 5x8 bearing, and then you mount everything in, and then you find with this opening where the slipper clutch, I guess thrust bearing, if you will, mounts. This also, it won't mount any further than this point, but you have a little bit of slack on this shaft now because everything's pushed further back. So you got a 5x8 bearing, and then you have to add a 4x8 bearing here that mounts inside this housing. And then from there, you could either just directly mount the spring, but I don't want that spring rubbing against the bearing seal. So then I just took this thrust bearing and added it on top of that 4x8 bearing. So I basically have 3 bearings now along this shaft. Then I put the spring down and tighten it down. And so that's what we have here. So in here is, between these 2 plates is a 5x8 bearing. And then in here is a 4x8 bearing that goes into this housing here. And then I took that thrust bearing and just slotted it right on. So now everything is, that basically that inner 4x8 bearing there kind of sets the thrust bearing to the correct offsets, and then you can mount this onto this part of the shaft, and there's no extra play or anything. And then with the spring, and it's all set. Everything's good to go. This particular spur gear is a Robinson Racing machined spur gear. It does fit on this assembly. It does have the right positioning of screw holes to mount onto this slipper clutch. All you have to do is bore out the inside hole a little bit. The stock fitting is a little bit too small of a diameter, so I just took a reamer and just bored this out a little bit. Or you can just take a Dremel, and just grind it out. And make sure that when you mount it, that as you rotate it, there's no wobbling back and forth. So there's a bit of hand fitting required there, but it does work. And the reason I did that is because these spurs are readily available, and they're machine spurs, so they're very high precision. These older Kyosho spur gears for the Pro X and the Rampage, you can still find them on eBay, but since they're uncommon parts, the people who sell them might charge you, say, $15 for one spur gear. I don't think that's too reasonable, so I figured I would just do this. And given the internal ratio of this gearbox, which is not the Pro X internal ratio, this is the Rampage Pro internal ratio, which is more like the truck, you end up needing something around like a 2-to-1 ratio between the spur gear and the pinion gear. So if you have an 80-tooth spur, you'll need a 40-tooth pinion. 75-tooth spur, you'll need something like a 37-tooth pinion, something like that, if you're going to put a stock, a 17.5 motor in this. So I'm going to start with the 75-tooth and see if I can fit something like a 37 with the amount of slack I have here on the motor mount. If it's too much of a gap, then I'll just increase this to what I have here, a 78 tooth, and then I'll try to go a little bit higher on the pinion, and maybe that'll close the gap. So this is where I am right now. Quite a bit of detail for the drivetrain. This is not a simple plug and play. You do have to do some custom work with, especially the slipper hub. You know, a little bit of work on the motor mount, but that's not too big of a deal. And then this is ready to go. Then I can install the rear tower, close everything up with the rear camber links, and then put the shocks on and a few other things in the middle here, and then it's all set. So that's it for now, and thanks for watching.